Hi everyone, welcome to video number 2 on the data types and variables playlist. And before we crack on, just a reminder that the YouTube site, the YouTube channel that you're watching this video on, you can of course subscribe to be aware of the latest uploads. There is a sister website at cscompendium.net where you will get extra resources and insights about computer science from both GCSE and A-level perspective, and you can hook up on Twitter at Endium Comp, where I will be tweeting and retweeting the hot topics in computer science and programming as they arise. So I hope you will join me on one, if not all, of those facilities. Okay, so let's do what we normally do with these videos, which is to leap in with a definition, and then we'll talk about the definition in a little bit more detail. So we're talking about the variable and the constant in this video. So two things, but actually they're very, very similar in the way that they are managed in a computer program. So we can say that a variable is actually the name that we give to allocated space in memory. It's given a meaningful name, which we call a label. Okay, so a variable has a label, which is a meaningful name, and it's used to store data for the duration of a computer program. Now, a constant is managed in exactly the same way as a variable. Okay, so a constant is also an allocated space in memory. It's given a label, which is a meaningful name. It's used to store data for the duration of a program, but because it's a constant, the data is not going to change. Okay, it's constant right the way through the program, just in the same way that you work with a constant in maths or in science. Okay, the value doesn't change. Okay, but in terms of how things, the mechanics of the computer program and how things work, they are both treated in a very similar way. And we'll talk a little bit more about that later on in the video. Excuse me, guys. So why do we need to have variables and why do we need to have constants? Well, let's give a couple of examples of where we need to use variables. A variable, okay, or variables can be used to store data, the value of which we actually have no idea about, okay, unless we ask Python to display it for us. Why on earth would we want to write a computer program where we have no idea what the value of the actual data is? Well, in actual fact, it may actually be a necessity that we don't know what the value of the data is that we're asking the computer to process. It may be security, for example, that we don't have sight of that data. But a practical example is if we are reading data in from a database, let's imagine it's 1,000 customer records of the amount of money that they spent over a period of time. Our computer program calculates the average amount of money that's been spent over, say, a month by 1,000 customers, and it outputs that particular figure, the average amount of expenditure. I don't need, as a computer programmer, and the people using my program don't need to actually see details about the customers. They just need that calculation to be done and for the outputs to be provided. But the only way that we can manage that, because we're not literally hard coding values into the program, the only way to manage that mystery data is to use variables and storage in memory. Now, conversely, there may be an example of a computer program, and in fact, you guys will be writing plenty of examples of this type of computer program where you do actually know what the value of the data is, but the data changes so often that the only way that we can practically manage changeable data is to store it in memory and call it a name, and the name of course is what we refer to as the variable. And later on in the video I will be showing you some practical examples of where we need to use variables to do exactly that. Now, when it comes to constants, we don't come across a constant in a computer program as much as we do variables. But when we do use constants, it's very often the case that we will hard code a constant into our computer program because it's a constant and we know what the value is. So for example, if we had a computer program to calculate the area of a circle, I would literally put into my computer program what the value of pi is, and you can see that at the bottom of the slide. Now you know that pi is not an exact number, so here I've chosen my level of exactness, if you like, my level of accuracy with pi to 3 decimal places, 3.142. Because I know what the value of pi is, I've actually hard-coded that into my program. What we don't know, of course, is the value of the radius. You can't tell that from the 2 lines of code. And in fact, the word radius you see on the screen is an example of a variable. So there you've got an example of a constant, which is pi, and you can see the value that's actually been written into the computer program. Radius is a little bit more mysterious because there we have a variable name. It relates to an area of memory where the computer program will store a value for the radius, but we don't know what the value of that radius is. It may have been provided from a file, from a user typing it in on a user interface, or it could have come from somewhere else. We just don't know, and it doesn't matter because what we're being asked to do here is to calculate the area, not to be specifically aware of the details like the value of the radius, for example. So to bring this to life a little bit more, to give you some examples of why variables and constants are important and how we work with them in Python, let's crack on and do some coding. So welcome back, and here we are in PyCharm. If I haven't mentioned PyCharm to you, I will do in the classroom. I would very much encourage you to download the free version of PyCharm. I won't go into any more details because it will make for a very long video, but what you're looking at is not Python idle, it's PyCharm. But everything you see in this video you will be able to code into Python idle and to follow me. There's no difference in the type of Python that I am using in this video. Okay, so let's start off by creating a new file, and we'll have a look at the basics of variables. I'll leave constants or the constant until the end of the video, I think, because I think it would be helpful to do variables first in terms of understanding. So new file, let's call it example1, or maybe not, because I've already got that one. Let's call it example2. Okay, so I'm going to, let's zoom in a little bit so you can see it in a bit more detail. I'm going to write a comment at the top. So we'll say prog1 basics in variables. We're just going to look at the basic mechanics for how we work with and name and use variables in a very basic program. Okay, let's start off with a program that doesn't use any variables at all, so you've got something to compare it with. So let's do print 12 plus 12, which you know is going to give us 24 if Python is behaving itself. Basically, we've got 2 integer data types, or Python recognizes them as integer data types, and we're going to add them together and we should get 24. So let's do that now. Okay, and you can see on the screen here, let me just show off with my little drawing tool again. We have the value of 24 that's been printed out on the console. No surprises there. And in fact, you know in advance what the answer is going to be because you can see the actual values, 12 and 12, hard-coded into the program. You can actually see them there. We call those types of values where you can actually see the value of the data that we're working in. We call those literal values. So these are literals. Okay, so we have literal values for integers, and we've got 12 and 12 gives us 24. Let's just take those off a minute. And of course, you know, just to emphasize the points, that I could of course change this to anything I want to, and we're basically using Python as a very crude calculator. There we have 132 to work out the values that we decide to give it in our code. Now, as I mentioned earlier on, there are plenty of examples where we don't actually know what the values of data are going to be, and we'll look at those a little bit later on. Now, to show you how variables work, instead of using 12 and 120, I'm going to define a variable with a sensible name, which we call a label. And of course, underneath the bonnet, what Python is actually doing is it's allocating a space in memory where it's going to store the data that we assign to the variable. That's the technical term that we use. We say to assign a value of data to a variable. Okay, so I'm going to give my variable a sensible name. So I'm going to call it my number one, and we're going to assign, we don't say equals because it's not maths really, we say I'm going to assign to the variable called with the label my num1, I'm going to assign the value of 12. Okay, and what I can do now, let's just zoom in a little bit more for you, is I can actually switch the literal value for the name or the label of the variable, okay, which is my num1. And if I now print that out on screen, you will see that we get exactly the same thing, which is 132. So what's actually happening here, there we go, there's 132 there. So what's actually happening here is that what Python is doing is it's recognizing the label for a variable, in other words, storage in memory. It goes away to the area of memory that it associates with our convenient name called mynum1. It retrieves the data in memory, it gets the data back from memory, it's of the value 12, it substitutes the variable name for 12, and it does the calculation as you saw earlier, which is essentially 12 plus 120. Now I can replace all of my literal data with variables if I wish. So let me just get rid of the two boxes. Okay, and in fact I can replace the literal value of 120 with a variable name as well. So what I'm going to do here, we're just going to copy this because it's going to be practically the same. Okay, so I'm going to pop in here mynum2, which is my second variable. I'm giving it a sensible label, which is mynum2, and I'm going to assign that the value of 20, and then here I'm going to exchange the literal value of 120 for my variable name or label, which of course is mynum2. Okay, let's run that and we should get exactly the same thing. Okay, so let's run it again, and you can see once again we get 132. So just to confirm the mechanics here of what's actually happening, we get 132. Okay, let me show off with my drawing tool again. We get 132 because Python gets the value that's been stored in memory with the convenient name mynum2, and it goes away and gets the value of the data that's been stored in memory, which we've called mynum1. Okay, brings that data out and then performs the calculation, which of course is 12 and 120. And you can see here the values that we've actually assigned to memory that Python goes away and processes. So this is a very basic example of how we can use variables in our program rather than working with literal values like the 12 and 20. Now it's not a particularly useful program, and it doesn't actually help to explain why variables are really useful, because you're probably looking at this and going, well actually I can still see the numbers 12 and 120 in your code, so why bother? Okay, so it's not a very good example to show you why it's useful, but it is designed to show you the actual syntax and the way that we work with variables instead of the literal values. Okay, so let's have another look at an example where we can see values being used in a more useful way. Okay, so let's create another program. So we're going to call it something very original like example 3. So let's do example 3 just so that I'm consistent. So example 3, we should give it some commentary, so put some comments in there. So I'm going to put example of user input, which is what we're going to be doing in this program. Okay, so example of user input to process the average of two numbers. Okay. Right, so let me spell average correctly, because that would be a help, and that's going to annoy me enormously if I have the underlining there for the rest of the video. So in this video, I'm going to use some computer code, some Python code, to pull in two values from the user. In other words, that's me in this particular occasion, using the keyboard. I will decide what those values are, but of course, if the program was being used by someone else, if you'd written the program, for example, and I was running it, you wouldn't know from one moment to the next what values I was going to type in on the keyboard. Now, in terms of Python code, I'm not expecting you to understand the code that I'm going to write. If you've not seen it before, that's absolutely fine. I'm writing the code just to demonstrate the usefulness of variables when we don't know what the value of the data actually is. Okay, so you're more than welcome, if you've not seen the syntax before, to get user input from the keyboard. You're more than welcome to study it. Otherwise, ignore it, and we're focusing on the use of variables. So I'm going to use a variable name again to get the data from the keyboard. So let's do what I did before. I'm going to say mynum1. Okay, let me just zoom right in so that you can see this better. I'm going to move the output screen over a little bit. So I'm going to say equals, and then we want input. Please input a number. Okay, and then I want mynum2, so this is my second variable to get the second number from the user. Okay, so mynum2 equals, and it's going to be very similar, so I'm going to say please input another number. Okay, and then I'm going to do some jiggery pokery to make sure that I'm working with the right data types. Okay, so I'm going to make sure I've got an integer. Like I said, don't worry about the syntax. If you're not familiar with it, don't worry. Okay, it's just to serve a purpose, really. So I've got two variables. One's called mynum1, the other's called mynum2. These are the labels that I'm giving to the variables. This is storage area. Okay, it's memory, where the computer will take input from the keyboard and it will store those values in memory. Okay, then what I want to say is average. So I'm going to create another variable with the label or the name average, so you can see a sensible name for the area that's allocated in memory. And I'm going to say that average equals, okay, and then I want mynum1, okay, plus, and then we want mynum2. Okay, and then we want to take those two and we want to divide by 2. Okay, then what I want to do is to print. Okay, and I'm going to say the average of your two numbers is. Okay, and then I am going to do some more jiggery pokery to make sure that the syntax is correct, and I'm going to put average in the print statement like this. Okay. Right, so let's run this, and then I can emphasize how variables can be a little bit more useful than the last example that we did. Okay, so I'm going to move the screen over a little bit, okay, and I may need to make this a little bit smaller. Okay, so I'm just going to clear this. Okay, and let's run this. Okay, so we're running example 3. Okay, it says please input a number, so I'm going to input some extremes of numbers so that we have a useful average that's calculated. So I'm going to start off with 12. Please input another number. So let's do 1325. Okay, and it says the average of your two numbers is 668. So that's the calculation that's been done. Okay, now the point that I wanted to make here is that you can see on the screen in the video the fact that I input 12 and 1325, but if you'd written this program and given it to somebody else, then you would have to rely on the fact that you've no idea what two numbers the user would put into the program. So there's no chance of reflecting any literal values in our code whatsoever. So just to emphasize the point again, I'm just going to move, let me just get rid of my red box, and I'm going to remove the input and output screen over to the right hand side. Okay, so basically if you look at the code, there's no way that you can tell what data is being managed. So what's Python actually doing with the data from the user and with memory and with variables? So basically what's happening is the first value that's read in from the user gets stored in memory. Okay, it's the variable name that has the label mynum1. Okay, so the variable name and the variable is an allocated space in memory. The second number that the user inputs is likewise stored in memory, and we've given it a convenient label called mynum2. Python then goes away, okay, and it takes the values that it's stored in memory, okay, it adds them up, divides by 2, which is the standard way in which we would calculate an average. It stores that calculation in a third variable or space in memory called average. Then when we are ready to do something with our mystery data that's been stored in memory, calculated and also stored in memory, we get to print that out here. Okay, so we ask Python to go away and find the value that it's calculated and stored in memory, which we've called average, and we've given it a sensible name, and it gets printed out on the screen. And the point that I wanted to make, even if you are unclear about the syntax of the code that I've written, the point that I wanted to demonstrate is we have a program here where there is no indication of any data at all. It's all values which are stored in memory, processed by Python from data and values stored in memory. The only time that we need to make those values available is when we are getting to the point of providing output in our code. Okay, so a much more, hopefully this is an example where you can see that variables are much more useful here, because the only way that we can manage input to our computer program is to assign the input to variables. And of course, what we actually mean by variables is allocated space in memory, where we get Python via our program to actually process that data. We don't know what it is because it's stored in memory, but we tell Python to go away and process it to find the average in this particular case, and then to output it onto the screen. And to emphasize the point even more, we could have asked Python to actually print the value to a file, and we wouldn't have it on the screen at all. The file might be made available to somebody else, for example. So there we don't see any real values of data whatsoever. It's all being managed in memory through the use of variables. So hopefully that example of the use of variables makes it a little clearer about how powerful variables actually are. Okay, so before we do any more practical programming, I've just taken us back to one of the slides that we were looking at a little bit earlier on in the video, just to summarize where we've got to. So let me get up my flashy drawing tool again. So in the last couple of demos that we did on PyCharm, I did a very basic but not particularly useful example of the mechanics of how we use variables, and we substituted literal values which are hard-coded into the program with the use of variables. And remember that all a variable is an allocated space in memory which we give a convenient and easy to use name, so that we can access that space in memory in a way that makes sense for us. Okay, so the last couple of videos we've really been looking at this idea here, which is to say that variables are used to store data, the value of which we may never know. And you saw that in the last demo where we were getting values from the user, we were processing that data, but it was quite possible actually that we never had sight in the program of the actual data that was provided to us. And it's only at the point where we need to do output that that data surfaces, if you like, and gets made available for people as useful information. So what we're going to do in the next demo is we're going to focus a little bit on this bit here, which is to say variables can be used to store data where we do know what the value is of the data, okay, or we can deduce it from the algorithm that our computer program is based upon, but it is simply not practical for us to use literal values. We need Python or whatever programming language we're using to do the hard work for us. And the way that programming languages typically do the hard work for us is to manage data that it stores in memory. And we're going to see an example of this in the next demo. Okay, so let's pop back to PyCharm and I will give you an example of the practicality of using variables versus not using variables. So here we are back in PyCharm. Let's create a new file, and I suspect it's going to be nothing more adventurous than the file name example4. But at least I am consistent. So let's create a new file. Let's call it example4. Okay, let's just make that a little bit smaller because we don't need all of that. Let's just type in some comments for my program. So example4. Okay, and let's say a program to print the numbers 1 to 10. Okay, so let's imagine that I've been given a requirement by somebody else simply to write a program that prints out the numbers 1 to 10. Okay, so easy peasy, because all I need to do is to print 1, okay, and then to print 2. So you can see here that I'm using literal values and that makes life quite easy. So I'm going to just copy and paste these and change the numbers. Okay, so let's do 3. Not long to go now because it's just 1 to 10. 4. Let's do the same thing. Let's change that to 5 to 6. Okay, and then we want 7, 8. And then we want finally 9 and 10. There we go. So let's run this and see what we get just to make sure it works properly. And there you can see in all of its glory, our program has printed out the numbers 1 to 10. And you can see that that makes perfect sense because on the left hand side of the screen, you can see the literal values of 1 to 10. And you can see that Python has printed out those literal values in between the brackets. So there's no use of memory. Well, there is. Okay, but in terms of variables, there's no use of allocated space that we have assigned to deal with our data because the values are there on the screen. Okay, so that works cool. But let's imagine that the person that asked me to write this program has come back and said, actually, I'm sorry, I made a mistake. It's not 1 to 10 I want you to print out on the screen. It's actually 0 to 5,000. At which point I stare at them and go, fine. That means if I do it this way, I've got to sit in front of my computer for hours, literally typing the values 0 up to 5,000. Okay, not something I would want to do, however keen I am to be using my computer. So in order to cater for something like this, we want Python to do the hard work for us. We certainly don't want to be typing in literal values. Okay, every single value from 0 to 5,000 inclusive. I want Python to do the hard work. And in asking Python to do that work for us, Python is going to want to work with a variable or variables and space in memory. Let me show you how this works. I'm just going to write the code. And once again, I'm not expecting you, if you've not seen the syntax before or iteration, which is what we're going to do, I'm not expecting you to understand the code. We're just going to focus on the value of using variables to make our life a little bit easier. Okay, so let's get rid of this because we don't need that anymore, thank goodness. And I'm going to write in here the following. I'm going to put for count in range, okay, 5,000, because that's where we are going to. That's what we're asking Python to print up to, and that's all Python needs to know actually with this particular technique. Okay, and then to print count. Okay, so question, because I'm not expecting you to understand what's going on here, but can you spot the use of a variable which has essentially replaced the need to program in hard-coded literal values from 0 to 5,000? Well, there's not a great deal to choose from because there's only a couple of lines of code. But in essence, our variable, okay, is here. So I have chosen a sensible label for my variable, called count. I could have called it anything. If I could have called it Fred if I'd wanted to, but I've stuck with a sensible name because we're asking Python to count literally from 0 to 5,000 and to print out the value that it's counting on the screen, which is what it's going to do in a second. So I've chosen a variable name. The allocated space in memory is called count. What Python is going to do is it's going to start off with 0. Okay, it's going to work with that value in memory. It's going to increment it by 1 to the value that's in memory. Okay, and it's going to retrieve that value and print out the new value plus 1 each time until Python gets to 5,000. Okay, when it's going to stop. And in fact, because this is Python, if I want it to print to 5,000, I've actually got to go up 1. Okay, so let me just get rid of this. I actually need to go up to 5,001 for reasons I won't go into in this video, but we'll come across this when we talk about loops and iteration in a future video if you've not seen this before. Okay, so let's run this and see what happens, and pay attention to the right hand side of the screen where we get output. Okay, so there we go. So believe it or not, in a fraction of a second, okay, if I just scroll up here, there we go, just let me just zoom in. Okay, if I slowly scroll up, we go to 5,000, and if I scroll up, you can see that Python actually started at 0, and in a fraction of a second it's basically printed out all of the values from 0 to 5,000 on screen, and it's very, very quick. In fact, let me do that again so that you can see how quick this gets processed. Okay, so I'm just going to run it here. Watch how quickly this happens. Okay, bang, right, 0 to 5,000. So it's a bit of a no-brainer, really, isn't it? The comparison between hard coding 0 to 5,000 and what Python can do once it's given a variable and memory to work with and the right programming syntax. Okay, it can do the hard work for us, and it can do it very, very quickly. So let's just go through and summarize what it is that I'm demonstrating to you here. Okay, by replacing literal values with using a variable, I'm able to ask Python to work for us simply by managing data in a variable or in memory. Okay, so in here, what we're asking Python to do, I'm saying to Python is, I'd like an area in memory, which I've conveniently called count, okay, which is indicated by this here. And then what I'd like you to do, Python, is I would like you to increment the value that's in memory by 1. So 0 becomes 1, 1 becomes 2, 2 becomes 3. And I would like you to do that in the range of 0 up to and including 5,000. Okay, and you keep on processing the data in memory and working with that for me. Okay, and then each time, okay, you increment the value in memory, print out the value that you have in memory, which is count. Okay, so we've done that in 2 lines of code as opposed to 5,000 lines of code literally printing out the literal values of 0 up to and including 5,000. Okay, so let's pop back before we cover off constants. Let's pop back to the slides and let's just summarize what it is that we've covered, because we've covered quite a lot of ground in the basic theory and understanding of variables. Okay, so we're back with the slides and we have covered off these two. So we've covered off variables, and we've looked at variables for managing the value of data that we have no clue about. Essentially, we're just asking our program to process data using memory and variables. And the example that we've just looked at is the practicality of not the impracticality of not using variables and trying to work with literal values. And hopefully the last video in particular made it very clear just how useful and powerful variables can be when it's part and parcel of an overall programming technique or programming syntax that we want to use. Okay, so I think we've covered off variables. The one thing that I need to cover off with you, and I am conscious it's quite a long video, so I suspect in class I would have directed you to particular parts of the video, so I'm sort of okay with that. So let's cover off constants. Okay, what did we say about constants? We said that for the most part, we create a constant in the computer program from a value that we actually know. Okay, for the most part, it's not always the case. We may get a constant from some other program, but for the most part, we will hard code a constant in because we know what it is. Okay, and once we've hard coded it in, allocated it to a variable, to a constant, I should say, then we can work with it quite nicely. And we're going to look now at an example of where we use a constant and a variable, and we're going to simply write a program to calculate the area of a circle, and you can see part of the code at the bottom of the slide there. So let's do that now. Okay, so here we are back in PyCharm, our last practical programming demo. We're going to look at a program which simply calculates the area of a circle. We have a constant in there, which is pi, and we're also going to work with the radius as a variable as well. And we're going to ask the user to provide us with a value for the radius. Okay, so let's do what we've done before. Let's create a new program. So I'm going to go up to the top and we will do new file program, Python file, and let's call it example5. Okay, I'm just going to clear this because it's going to get a little bit annoying. Let's move that over. Let's make it a little bit bigger. I'm going to put a comment in here which says program to calculate the area of a circle given the input of the radius from the user. Okay, so we're going to be using similar input code to what you saw in the previous video. Once again, don't worry about the syntax here. It's just an opportunity to show you how a constant and another example of a variable can work in a program. Okay, let's just zoom in a little bit. So program to calculate the area of a circle given the input of the radius from the user. So the first thing that I'm going to do is to show you how we allocate a constant in Python. So I'm actually going to put in a comment, and I'm going to put in here constant. Okay, and then I'm going to put pi in uppercase, because this is the convention in Python that we use with constants. If we are allocating a label for a constant in Python, we always name the variable in uppercase. Okay, so pi in uppercase. So I'm going to say pi equals, and then I'm going to put 22/7. Python will allow me to allocate a value for memory, which is actually an expression. Okay, so it doesn't just have to be 3.142. I can actually leave it as a fractional expression of pi 22/7, and Python will manage the maths whenever it needs to work with that particular value of pi. Okay, now there's something very, very important about constants, or the use of a constant in Python, because Python doesn't actually have the concept of a constant in the language. Now, in most programming languages, we would do something like this. I would say constant. Okay. If it was Java or C++, it would be something similar, where I am specifically saying to the programming language, this value, this label is a constant. Once I've done that, in other programming languages, it is not possible to change that value. Okay, so if I wanted to change pi and I wrote a line of code which says pi equals pi plus 5, I would get a syntax error, because in other programming languages, once I have done this, which is to name my allocated space in variable in memory as a constant, I can't change it. Now Python doesn't have that restriction. You can actually change a value in memory regardless of whether it's supposed to be a constant or not. So what I'm trying to say here actually is that in Python, okay, all we work with is variables. If we want to allocate a variable as a constant so that the data doesn't actually change, the best we can do is to put a comment in the code for other programmers to say, actually, this value is a constant. You should be able to tell because it's in capital letters. Okay, and as a really good programmer, you're not going to change it if you are modifying or maintaining my code, are you? Okay, that's the way that it works in Python. And in fact, there's a much bigger discussion which I'm not going to cover in this video about the whole philosophy and approach that Python takes to basically passing responsibility to the programmer rather than putting very tight restrictions in place as to what you can and can't do. Okay, but that's a story for another time. So this is the way that we designate or work with a constant in Python. We simply allocate it as a variable, give it uppercase, but call it a constant by putting some comments in the code. Okay, so this is my version of a constant. It's actually a variable. Okay, but I'm asking anybody that looks at my code to treat pi as a constant and not to change it if they change my code. Okay, so pi equals 22/7. Then what I'm going to do is I'm going to get a value of the radius from the user. So I'm going to say radius. That's a very sensible variable name. Okay, radius is allocated input from the user. So I'm going to say input. Okay, and let's say please input an integer for the radius of your circle. Okay, let's just zoom out so you can see that a bit better. Okay, or see it in its entirety. Okay, so radius of circle. Okay, and I'm going to do a bit more jiggery pokery, and I'm going to just put in an extra syntax here to make sure that I am actually working with an integer. Okay, more on this some other time in some other video. Okay, so I've now got a value from the user of the radius. Okay, and that will be stored in a variable which I've conveniently called radius. So now actually on the code so far, I've got two variables. One's called radius, the other is called pi, but to make sure that pi gets treated as a constant rather than as a variable, I simply put a comment in the code saying, please treat this variable as a constant. Okay, like I said, other programming languages, you can actually designate a label and allocate space in memory as a constant, and once you do that, basically it's fixed and it can't be changed. Okay, but Python's not like that. So now we need to do the calculation. Okay, so I'm just going to put a comment in here, get the radius from the user, which is what that line of code does, and then we're going to do calculation. And the calculation for the area of a circle, quite simply, in its simplest form, is to say area. So there's another example of a variable. Okay, I've given it a sensible name, area, space in memory, which I've conveniently called area. Okay, area is assigned with the result of the calculation, which is, okay, it's going to be radius multiplied by the radius. Sorry, it's going to be radius. Oh, actually, let's do it properly. Let's do pi. Okay, I'm not sure why I was wanting to do it back to front then. Let's do, it's pi r squared. So let's do pi multiplied by the radius. Okay, multiplied by the radius. Okay, we can do the equivalent of squared in Python, but it's a little bit more complicated because it involves importing code from another library, and I'm not going to do that in this video. So I'm just going to say r squared is the equivalent of just saying radius times radius, which is what I've done here. Okay, so area is pi times the radius, and then we're just going to print out okay, so we want to print, and then we want to say the area of your circle is, all right, and then we want space, and then more jiggery pokery. So I want to do string equivalent of area. Okay, you can probably guess what's going on here, but I'm not going to spend time on explaining syntax because it's just demonstrating the use of a constant in Python. Okay, so let's run this now. All right, so let's do run. Okay, let's just move this over. So it says, please input an integer for the radius of a circle. Let's do 10, because that will be easy to see that we've got the right calculation. Okay, and it says the area of the circle is 314.2857. That we know is going to be roughly correct because pi is 3.14. If we times it by 10, okay, that's the equivalent of timesing 3.14 by 100. Okay, roughly gives us 3.142857, etc., etc. So the calculation is correct. The program works correctly. Okay, and we have made use of a constant in Python. Okay, so just to summarize very quickly what we were saying. Okay, in other programming languages, when we allocate a label to a constant, when we use the correct syntax in something like Java or C++, okay, we cannot change that value. It is literally fixed in the program, which is the whole idea of a constant. Python's slightly different. We don't actually have constants or constant in Python. We have to use a variable. And what we do in Python is we simply put a comment in there saying, basically, please treat this variable like a constant, so don't change it. And to help that, to help make sure that that happens, we also have a convention where the name or the label for a constant is in uppercase. Okay, so you can see here that to comply with convention in Python, I have called my variable, okay, which we're using as a constant, and I've called that pi in uppercase. Okay, then what we've done is we've got the input of the radius from the user, and I've stored that value conveniently in a variable called radius. It's not a constant because radius could store any value from the user. Okay, and then what I've done is I've done a calculation where the result of calculating the area of the circle is stored in another variable called area, and then finally our value for the area is output. Okay, and then we ask Python to retrieve the value that's been stored in the variable called area and to print that out on the screen. Okay, and because we used a sensible radius of 10, we can use that to roughly check our calculation is correct. 3.14 times 10 times 10, we know it's going to be about 314, which is what we had on the screen here, 314.2857, okay, the area of your circle. Okay, so that brings us to the end of the practical demo. So let's pop back to the slides then, and we'll just wrap up and summarize very briefly. Okay, so let's just wrap up with a summary of some of the key points which we have been addressing in the slides, but also with the practical demos as well. So back to the definitions then. Basically, very similar definition for a variable and a constant. We said that a variable is a space in memory. It's an allocated space in memory that's given a label, in other words, a meaningful name, and it's used to store data for the duration of a program. Constant is exactly the same, except that we call data that we don't want to change a constant. So a constant is space in memory, just like a variable, has a meaningful label or a name, but it's used to store data for the duration of the program, which is not intended to change. Importantly, though, you will have picked up from the demos that Python doesn't have the concept of a constant. In Python, you just have variables, and if you want a variable to behave like a constant, the best that you can do is to flag that by giving your label name uppercase syntax, okay, or uppercase for all of your characters for your label name, and you have to put a comment in the code which says, please don't change this, it's supposed to be a constant. And you saw an example of that where we allocated pi in the program to a label. Python manages that as a variable. The best that we can do is to give it an uppercase name and to put a comment in the code. Okay, now that's very different from other programming languages where to one degree or the other we can actually enforce the idea of a constant, and if we flag a label as being a constant in the programming language, then it's not possible to change that during the program. It's a fixed value. Okay, we've also looked at a couple of important scenarios where variables are really indispensable. The first one is that if we need to manage data where we have no idea what the value of the data is, we're just asking Python or a programming language to process data until we get to the point of output, then the only way that we can do that with unknown data is to use memory and to give allocated memory a sensible name so that we can work with it. Also, we saw with the example of counting, we also need to be able to use variables because it's simply not practical to have to hard code literal values into a program. We need a programming language like Python to do the hard work. And the way that Python does that is to ask for a variable name or the names of variables, and then to work its magic by working with data in memory. Okay, so that brings us to the end of this video. It's been quite a long video. Okay, so I'm assuming that you split the video into sections rather than doing all of it in one go, which is cool. And I will see you in the next video where we are going to be looking at techniques for changing a data type so that we can have a more flexibility in what we do with data of a particular data type. See you in the next video.